Hello friends, as we have seen the first chapter of data structure, introduction to data structure, now we move forward to the linear data structure. The linear data structure such as array and linked list allows us to delete and insert an element at any place in the list, either at the beginning or the end or even in the middle. However, sometimes it is required to permit the addition or deletion of elements only at one end, that is either at the beginning of the end or the end of the list. Now we move forward the another type of linear data structure, queue and stack. Stack and queue are two types of data structure in which the addition or deletion of an element is done at end rather than in the middle. Okay, now we start the stack. A stack is a linear data structure in which all insertion and deletion are made at one end, called the top of the stack. It is very useful in many applications, such as we see stack of plate in restaurant, stack of books in bookshop. Even a packet of papers is also a stack of paper sheet. A book is also a stack of written papers. When anybody takes a plate from a stack of plate, he takes it from the top. For the shipment of goods, they have to be loaded into a cargo. During unloading, they are unloaded exactly the opposite order as they are loaded. It means the goods which are loaded last should be unloaded first. A stack is an ordered collection of homogeneous data element where the insertion and deletion operations occur at only one end. This end is often known as top of the stack. Here, the last element inserted will be on the top of the stack. Since deletion is done from the same end, last element inserted will be the first element to be removed out from the stack, and so on. That is why the stack is also called last in first out. Initially, when stack is created using arrays, the size is fixed. The stack base remains fixed while the stack top changes the element are inserted or deleted. So most frequently accessible element in the stack is the top and the last accessible element is the bottom of the stack. Figure shows the creation of stack and its operations. It means insertion and deletions operation in stack. Now we move forward about the operations on stack. There are mainly two operations performed on the stack. First one is the push operations, which allows adding an element at the top of the stack. Second one is the pop operation, allows to remove an element from the top of the stack. First we start with the push operation. The process of adding an element to the top of stack is called push operation. Pushing an element in the stack involves adding of element at the top. Suppose after inserting an element, max size is reached, it means stack is full, and if we want to insert one more new element, it is not possible to insert any new elements. The situation is called stack overflow condition. At this point, the stack top is present at the highest location of the stack. Now we see the algorithm for push operation on stack. First, we need to check for overflow conditions. How we can check the overflow conditions? If top is greater than equal to n, then we can write stack is overflow, insertion is not possible. Otherwise, we increment the top is equal to top plus 1 and then insert the new element x in the stack. So we can write stack of top is equal to x. This is how we can add the element on the top of the stack. Okay, now we move forward about the pop operations. The process of deleting an element from the top of stack is called pop operations. After every pop operation, the stack is decremented by 1. Finally, when all the elements are deleted, top points to bottom of the stack. When stack is empty, it is not possible to delete any element and the situation is called stack underflow. Thus, if there is no element on the stack and the pop operation is performed, then this will result into underflow conditions. So let's start with the first step of pop operations. First we need to check for the underflow condition on stack. How we can check? If top is equal to 0, then we can say stack is underflow, deletion is not possible. If stack is not underflow and deletion is possible, then write top is equal to top minus 1. We decrement the top pointer and remove the element from the stack, and this is how the pop operation was done on the stack. Next is peep operations. It is also possible to verify the item placed at the top of the stack without removing it. This operation is called peep operations. Thus, determining the top element of a stack without removing it from the stack is called peep operations. For performing the peep operations, we also need to check for underflow conditions. If there is any element in the stack, then we can display or we can show that element as the output. So in peep operations, first we start with check for stack underflow. As usual or as previous algorithms, we can also check by if top is equal to 0 or top is less than 0, then stack is underflow and peep operations is not allowed to perform. Otherwise, return the last element where top is indicated, and this is how the peep operations is performed on stack. Another operations, which is change operations. Which element we can show by the peep operations. Also we can alter or change this element by using the change operation in stack. Start from the underflow conditions. If there is any element, then and then we can change the element. So start with the underflow conditions. Check underflow conditions by top minus I plus 1 less than equal to 0 or by top is less than or equal to 0 conditions. If stack is underflow, then change operation is not performed on the stack. Or if stack is not overflow, then change ith element from top of the stack by using stack of top minus I plus 1 replacing by the element x. This is how the operations are taken place in the stack. Now we move forward. The applications of stack. There are 4 applications of stack. First is the recursion, second one is the evaluation of expressions, third one is the reversing characters, and fourth one is the tower of Hanoi. These 4 are the applications of stack in which the concept of stack are justified and used for performing all of these 4 operations. Okay, so this is how the basics of stack are work. This is the operations of stack, applications of stack, and how we can understand the basics of linear data structure stack. If you found any query